So in the last class, we were doing atoms and molecules, right? And in there, we studied about atomic masses and molecular masses. So we just calculated the molecular masses of certain substances. Okay. So what is an atomic mass? Atomic mass is the mass of an atom as compared with carbon 12 atom. So 1 AMU is the atomic mass unit. 1 AMU, or sometimes it's also written as U only. So 1 unit or 1 atomic mass unit. This is equal to 1 over 12 of 1 by 12th of mass of carbon 12 atom. 1 AMU is equivalent to 1/12 of the mass of carbon 12 atom. This is what we call as 1 AMU or 1 atomic mass unit. Okay, this is not gram, kilogram. This is in the case of gram and kilogram, we compare it with kilogram. Okay. So what all yesterday we did atomic symbols.
So why do we only take carbon atom and not some other atom?
As carbon is versatile.
Oh.
Okay, carbon is versatile. It's available everywhere in every form. So that is why we take carbon 12 as standard for it. So in the last class, we also studied of certain symbols which are used to represent the atomic masses. Then after 1 AMU, we studied about the symbols starting from atomic number 1 to we studied atomic number 1 to 20 along with symbols. Then we studied some other elements. We also tried to form molecular masses. Molecular masses. So this was what we had done in the last class. Now we will be studying about today. We will study about Dalton's theory, law of
Sir,
conservation of mass.
so one atomic mass unit is 1/12 of carbon 12 massive massive carbon 12 atom 1/12
Yeah.
for anything.
For anything means
Like one atomic mass unit is the same for everything.
yeah, it will be same. So if suppose an and something has an atomic mass of 24 AMU. Okay. So it means the mass of this substance will be double the mass of carbon.
Okay, sir.
Okay. So symbols we had studied. We also studied about the molecular masses. Now today we will be studying about Dalton's theory. We will study about the conservation of mass in a chemical process. And we will also study about law of definite proportions or law of constant proportions. This is what we are going to study today. Dalton's theory, conservation of mass, and law of definite proportions. We'll start with the conservation of masses. So when we say conservation of mass, it means in a chemical reaction, whenever a chemical reaction occurs, in a chemical reaction, the mass is neither created nor destroyed. This is what it means. When you say conservation of mass, so it means in a chemical reaction.
Sir, in NCRT, there's an example given when it gets broken down, it's still the same amount. Like, there's an example like that.
Okay, just we will see some examples. So in a chemical reaction, what happens? In a chemical reaction, mass is neither created nor destroyed. So mass can neither be created nor destroyed. So what it means that the total mass of the reactant should be equal to the total mass of products. Suppose there is some reaction between carbon and oxygen. So let us suppose there are 12 grams of carbon, there are 32 grams of oxygen. So the carbon dioxide which will be formed, this carbon dioxide, it will have a mass of 44 grams. There will not be any loss of mass. Okay. Carbon is 12 gram, oxygen is 32 gram. So the total mass of the reactant, if you observe, the total mass of reactants, so total mass of reactant is 44, and therefore the total mass of the product will also be 44. Okay. So when it will become 44? When all the reactants react and they get converted to the product, so you will have a total of 44 gram of carbon dioxide. So you cannot create a mass and you cannot destroy the mass in the case of a chemical reaction. In any chemical reaction, the mass remains conserved. Similarly, we can see with the reaction of water, right? Hydrogen and oxygen combining together to form water. Let us suppose you have 4 gram of H2O combining with 32 gram of oxygen. So this will give you 36 gram of water. Okay. So I hope everyone has understood this conservation of mass. Okay. Pranaya,
Yes.
turn on the camera.
Okay, so 1 second.
So we saw, I think everyone has understood. Okay, let's see. Carbon combining with oxygen to give you carbon monoxide gas. Okay. Suppose you have 24 gram of carbon and here you obtain 56 gram of carbon monoxide. So how many grams of oxygen will be required? How many grams of oxygen will be required?
32.
32. Okay. So if you check up, if you subtract 56 minus 24, you get 32. So 32 gram of oxygen is required for the reaction to complete. Okay. So this is your simple conservation of mass. That means in a chemical reaction, the mass can neither be created nor be destroyed, which means the total mass of the reactant should be equal to the total mass of the product. Then in the similar way, our next is, okay, next one is law of definite proportions. So let's see the next one, that is law of definite proportions. So what is this law of definite proportions? It means that whenever atoms combine or if a molecule is formed, so the combining atoms, they always combine in a fixed ratio by mass. Okay. So in a molecule, atoms always combine in a fixed ratio by mass. combine in a fixed ratio by mass. So in the law of definite proportions, in any molecule, if you take any molecule, so in that molecule, whatever combining atoms are there, you will always find them in a fixed ratio by mass. They always follow a fixed ratio by mass. For example, if you consider, let's say CH4, this is methane CH4. Now, if you find out the ratio of mass of carbon to the mass of hydrogen, so the ratio of mass of carbon to the mass of hydrogen in CH4, it will always be 3:1. How we obtain this? Here the mass of carbon will be 12 and mass of hydrogen is 4. So 12:4 is equal to 3:1. Whenever you will have CH4, it will always have it in the ratio of 12:4, which is 3:1. Got it? Law of definite proportions. So, can you determine the ratio of molecules in ratio of the masses in let's say, determine the ratio of masses in NaOH. Also, calcium hydroxide. What is the ratio of the masses? Here you will find the ratio of sodium, oxygen, and hydrogen. Here you will find the ratio of calcium, oxygen, and hydrogen.
So the first one is 23:16:1, right?
Okay, so the first one is 23:16:1.
Yeah.
Okay. What is for calcium hydroxide? Calcium, oxygen, and hydrogen.
Sir, are we allowed to look up the atomic masses?
Yes.
So 20:16:1.
You have 20:16:1. Okay, so that is perfectly correct. Who got this?
So Harini.
Okay. Varshita? Varshita? You are not calculating? Yes, Varshita. And did you calculate the ratio of the masses of calcium to oxygen to hydrogen?
Can you once again show how you did it? Like,
Okay. Just look up in this molecule. In this molecule, you have one atom of calcium. You have one atom of calcium, two atoms of oxygen, and two atoms of hydrogen. Okay. So calcium has atomic mass 40. The mass of calcium will be 40 in one molecule. In one molecule, the mass of oxygen will be 32, as there are two atoms. So it will be 16 into 2, which is 32. For hydrogen, there are two atoms of hydrogen. So you will make 1 into 2, which is 2. Now, if you find the simple ratio between them, so the simple ratio between them is Aman, what is the simple ratio? 20 ratio 16 ratio 1. So wherever you will find calcium hydroxide, it will contain it in the same ratio. Can you find out for H2SO4? For H2SO4.
So is it 1:16:32?
Yes, sir.
Okay, is there anyone who obtains the same ratio?
Sir, I got.
Okay,
Sir, even I got the same answer.
okay. And who is not getting? Prince,
Yes, sir.
are you getting?
No, sir.
Okay, what is the mass of hydrogen that is present in H2SO4?
Sir, 1 into 2.
1 into 2, so we write here 2. Mass of sulfur?
Sulfur,
Yeah,
32.
32, very good. What is the mass of oxygen?
16.
16. Okay, so can you simplify the ratio?
Yes, sir.
Okay, so what
Sir,
will be the final
16
ratio?
into 4, 64.
Okay, so this will be 16 into 4, that's 64. Now, if you simplify the ratio, you get 1 ratio 16 ratio 32. Okay, all the ratios, they have a common factor. So if you okay, now let's try to find out for Fe2O3. Okay, find out for Fe2O3.
So iron's atomic number is 30, is it?
No, iron's atomic mass is 56.
What
56 AMU. Yeah, Chavan Kaushik,
Yes, sir. Hello?
Varshita.
Sir, can I post it in the chat?
Yeah,
Can I post the thing in the chat?
yeah, you can post it in the chat.
We're only finding out the whole atomic mass ratio, right? That's it.
Yeah, we are just finding out the ratios.
Sir, is it 3:1?
Okay, you are getting 3:1.
Oh,
Just
never
wait.
mind. 2:1. I mean 2:3. Sorry. Okay. Yeah,
I'm getting
2:3.
7 is to 3.
No, isn't it 2:3?
So even I suggested that.
Okay, it will be 2 times 56.
Sir,
And the
4
ratio
ratio
is 16 times 3.
Oh, let me do the calculation.
So if you simplify,
7:2.
you have the ratio 7:3.
Sir, but should it not be oxygen and Fe?
We are finding the ratio of masses.
No, but the weight of oxygen in Fe2O3 is 48 to 16, which simplifies to 3:1.
Okay, I think there are some glitches.
No, sir.
No, I'm getting a double voices echo.
Even I'm getting your echo, sir.
Yeah.
Of my video / audio.
No, of my own.
Oh. Sir, you can try rejoin.
Okay, just check who was getting an echo. Check it out. Is it still echoing?
No, sir.
Okay. So up to now we have done finding out the ratio. Up to now we have also done so what all we have done up to now. We are now left with Dalton's atomic theory. So K. Subhacharvik, are you able to get it? That every time we are not measuring just the number of number of the atom, but we are measuring. There was someone's mic was on, and that's why I was getting an echo. So Dalton's atomic theory. We will see some of the key points of the Dalton's atomic theory. Okay, just wait. Okay, so yesterday we were talking of the symbols of the elements. As you can see, here are some of the symbols given. Okay, so these were used in the olden days. The symbol of hydrogen, carbon, sulfur, phosphorus. All these were the symbols which were used in the olden times. But now they are not used. Now we have those symbols of the elements. They are made by their Latin names. Okay. Also in the till then, just solve out this question. In a reaction, 5.3 gram of sodium carbonate reacted with 6 gram of acetic acid. The products were 2.2 gram of carbon dioxide, 0.9 gram water, and 8.2 gram of sodium acetate. Show that these observations are in accordance with the conservation of mass. So you have to show that these observations, they are in accordance with the conservation of mass. The reaction is written here. So these are the questions that you have to do. First, try to solve the first one. Abhinav, Pranaya, and Chavan Kaushik. Solve the first one. In a reaction, the reaction is also given. So in a reaction, 5.3 gram of sodium carbonate reacted with 6 gram of acetic acid. The
Yes,
product.
sir, I solved it. So the mass of okay, sir. So over here, the mass of conservation states that mass of reactants is equals to mass of products. So 5.3 grams of sodium carbonate plus 6 grams of acetic acid is equals to 2.2 grams plus 0.9 grams plus 8.2 grams. So 11.3 grams is equals to 11.3 grams.
Okay, so mass of the reactant is equal to the mass of the product.
Yeah, because 2.2% carbon dioxide, 0.9 grams water, and 8.2 grams sodium acetate. All of it sums up to equal because matter cannot be created or destroyed, so it has to be equal.
Okay. Sodium acetate plus you have carbon dioxide plus water. So initially you have 5.3 gram sodium carbonate. Your acetic acid is 6 gram. Sodium acetate is 2.2 gram. 2.2 gram of carbon dioxide, 0.9 gram water, and 8.2 gram of sodium acetate. 8.2. This is 0.9. So if you add all the reactants, so mass of reactants comes out to be equal to mass of products. So look up the question number 2 now. And this, who will answer? Let me see. Aman will answer. Okay, Aman and Prince will answer this. Everyone will solve. Solve question number 2. Hydrogen and oxygen combine in the ratio of 1:8 by mass to form water. What mass of oxygen gas would be required to react completely with 3 gram of hydrogen? Okay. So this is a simple ratio. Let me see how you are able to do. Aman, have you got the answer?
Sir, is the answer I said the correct?
How much?
I said the answer. Can I tell you?
Yes.
I got 24 grams. Sir.
Okay. See, as per the, if you take up the ratio, so as per the ratio of constant proportions, hydrogen and oxygen, the ratio of hydrogen and oxygen, it will always be 1:8. It should be 1:8. Okay. And if you are given here, hydrogen is 3 gram, you have to find the mass of oxygen. So let the mass of oxygen be X.
Sir, 3 grams of hydrogen atoms and 24 grams of oxygen atoms are required.
Yeah, so you just cross multiply here, you get your X equals 24 grams. Okay, if there are 3 gram of carbon, so how many grams of oxygen are required? You will tell how many grams of oxygen are required to form carbon dioxide.
So can you repeat?
You have 3 gram of carbon. You have 3 gram of carbon. So how many grams of oxygen are required to form carbon dioxide?
Twenty-four gram.
24 gram. Okay, who is saying 24?
Semi.
Okay, Prince is saying 24. Okay. Anyone else who has got the answer? Varshita, have you got the answer? Okay, so speak up. What is your answer? How many grams of oxygen are required? Unmute yourself, Varshita. Unmute. No, Varshita, you are not audible. You are not audible. I can see you are trying to speak, but okay, you are now connected audio. No, again not audible. Check it again. Unmute and check. Okay, I think Varshita is facing some issues. She is not able to get with the audio. Okay, anyone else who will tell the answer? Aman,
Sir, 8 grams only.
8 grams. Okay. Anyone else? Harini, how many grams of oxygen are required?
Sir, I'm still solving this.
You are still solving this.
I
See,
got him.
first you find out the ratio of carbon and oxygen in carbon dioxide. So what is the ratio of carbon and oxygen in carbon dioxide?
3:8.
3:8.
3 is to 8. Okay. So here 3 is to 8 is equals to 3 over x. So our x equals 8 gram. Only 8 gram of oxygen are required, not 24. Okay, Varshita gave 2 answers. So I hope, okay, anyone who is finding difficulty in finding out these problems?
Sir, like I don't know the carbon and oxygen ratio.
So you
Like,
need to
is there a table for those ratios?
no, there is no table, but you need to calculate the ratio, like we just did over here. I think in the previous
Oh,
slide,
okay.
here we did the
Okay, sir. I
calculation
got.
of the ratio. Okay. So, okay, we will try one more question. Fine. So, which compound, let's say you have carbon and hydrogen, or let's say hydrogen and oxygen you have. You have hydrogen and oxygen forming water. If you have 4 gram of oxygen, so how many gram of hydrogen are required? You will tell this. Then the next one is, let's say, carbon plus hydrogen giving methane, CH4. And if you have 2 gram of hydrogen, so how many gram of carbon are required?
The first one I got a weird answer. Like, I don't think it's right.
Sir,
Okay.
even
Hmm.
me. I got 0.5.
I
Even
got
I got
one.
0.5.
Okay. In the first one, you are getting 0.5.
I got
Yeah.
one, sir.
Okay. So it is 0.5 only. For the first one, it is 0.5. Okay.
How,
So what?
sir?
Okay. What? How?
Like, how is it 0.5?
See, first you find out the ratio of hydrogen and oxygen from water molecule. In the water molecule, if you find the ratio of hydrogen to oxygen, it is 2:16 or 1:8, right?
Yes, sir.
Okay. So the ratio is 1:8, and here you have 4 gram of oxygen. So we take the oxygen ratio to be 8, 4, and let us suppose we have here x. So our value of x will be 4/8, which is 0.5.
So second one I got 6 grams.
Okay. Okay, so second one you got 6 gram. Anyone else? Okay, Chavan, are you getting the answer?
Yes, sir.
Okay. So I think everyone can now obtain the answers. Is there anyone who has not understood, like Aman, Prince, Siddhant?
No, sir, no doubt.
Okay. So now we move towards the Dalton's theory. Here we just saw if you find out x, it is okay. It's straight. So if you find out the ratio is here 12:4. That means 1:3. Okay. So they are present in the ratio of 1:3. If you have, so not 1:3, 12:4 means 3:1. So if you have 2 gram of hydrogen, again you can calculate in the same way. You will require over here 6 gram. Now let's see Dalton's atomic theory. So here we have the postulates of Dalton's atomic theory. We will see each point. These are the postulates of the Dalton atomic theory. That means what the Dalton atomic theory states. We will see each point by point. So at the first point, Dalton's atomic theory it states that all matter is made of very tiny particles called atoms, which participate in chemical reaction. So all the matter it is made up of tiny particles which are called atoms. Now the search for these atoms, if you in the Indian philosophy, you find a name of there is some Maharshi who
So
came to be
Maharshi
known.
Kanad.
Yeah, Maharshi Kannad. You have Maharshi Kannad who states about Anu and Parmanu. So this was a philosophy. We did not have any scientific proofs, experiments, related things with it. system. Okay, so here we see that all matter is made of very tiny particles called atoms. Okay. So we are talking of Maharishi Kanath, who had talked about Anu and Parmanu. So Anu was the purest form, which were called as the atoms, to which Dalton called as atoms. But there were no studies regarding these, there were no proofs. Okay, so it was a philosophy which was given. Like suppose if you take a piece of wood and you cut it, so what is the smallest piece you obtain that you cannot cut? Okay, so cannot cut means with any effort, with any technology you cannot cut that. So that smallest piece which cannot be broken down further, to that we call as an atom. So all the matter, everything that we see around us is made up of atoms. All the chair, table, everything we see, that is only made up of atoms. So this was the Dalton's first postulate, that all matter is made of very tiny particles called atoms, which participate in chemical reactions. So it is the atoms which participate in a chemical reaction. Okay. In a chemical reaction, they participate. That means they help in the formation of new substances. Now, second point, it states that atoms are indivisible particles. Indivisible particles means you cannot divide atom further. Like yesterday we discussed that we can break atom into electrons, protons and neutrons. Okay, but electrons, protons and neutrons, they do not have their independent existence. They cannot exist independently. Okay, so atoms are indivisible particles. They cannot be divided further, which cannot be created or destroyed in a chemical reaction. But some of the scientists, they believe that yes, this point is false. Nowadays, we can break atom. Atom can be broken down to a nucleus and electrons. Okay, so atom can be broken down, and that is why they say that this point is false. So this was the older time, the first one that we are obtaining about the atoms. So atoms are individual particles which cannot be created or destroyed in a chemical reaction. Atoms cannot be created or destroyed in any chemical reaction. Then atoms of a given element are identical in mass and chemical properties. Atoms of any given element, they are identical in mass and chemical properties. Means, suppose if you take atoms of carbon, we take atoms of carbon. So whatever atom of carbon you can take, that will be similar in its all respect. Okay, but this point also was proved later on false with the discovery of isotopes and isotopes. Okay, but here atoms are individual particles. So atoms are of a given element are identical in mass and chemical properties. That means if you take an atom of carbon, so its mass will always be 12 AMU. Okay, and it will always have 4 electrons in its outermost shell. So this property, this is your third point, that atoms of a given element are identical in mass and chemical properties. Okay, then atoms of different elements, if you take the atoms of different elements, so atoms of different elements have different masses and chemical properties. If you take an atom of carbon and if you take an atom of oxygen, so they will have different chemical properties. They will have different atomic masses. This carbon will have an atomic mass of 12, whereas oxygen will have an atomic mass of 16. So whatever different element if you take, their atomic masses will be different. For example, if you take carbon and nitrogen, so carbon has atomic mass 12, nitrogen has atomic mass 14. So atoms of different elements have different masses and chemical properties. And if they are the atoms of same element, then they will be similar in their mass and chemical properties. Then fifth one, we just saw that atoms combine in the ratio of small whole numbers to form compounds. That atoms always combine in the ratio of small whole numbers. And just now we determined just now we determined the ratio of those masses. Okay. We determined the ratio of masses of iron and oxygen present in Fe2O3. We determined the ratio of hydrogen and oxygen present in water. So atoms combine in the ratio of small whole numbers to form compounds. Then the relative number and kind of atoms are constant in a given compound. If you take any given compound, so the relative number and kind of atoms are constant in a given compound. For example, if I take CH4, so it says that there will be 1 atom of carbon and 4 atoms of hydrogen in every molecule of methane. Similarly, if you take H2O, so according to this statement, it means that water will always contain 2 atoms of hydrogen and 1 atom of oxygen. So the relative number and kind of atoms are constant in a given compound. For any given compound, the relative number and kinds of atoms are constant. So these are your 6 postulates of Dalton atomic theory.
Sir,
Yes.
but then when we talk about isotopes, this third postulate becomes wrong, right? Atoms of given element are identical in mass and chemical properties.
Okay. So if you see, if you look up all of them, so even your first point is also wrong. Okay. All matter is made of very tiny particles called atoms which participate. Okay, this is right. All matter is made of very tiny particles called atoms which participate in chemical reaction. But the second one, atoms are indivisible. This is false, as atoms can be divided into electrons, protons, and neutrons. Then
But
atoms.
electrons, neutrons, and protons can't be independent. So maybe second one is right, but the third one I feel like isotopes are it's wrong.
Okay. So your third one, atoms of a given element are identical in mass and chemical properties. So here you give the example of isotopes. It is the existence of the isotopes which proves that atoms of a given element are may not be identical. For example, carbon has 2 isotopes, carbon 12 and carbon 14. So carbon 12 and carbon 14, they are the atoms of same element, but they are having different masses. Carbon 12 and carbon 14. Then if you see the fourth one, this one is also false, that atoms of different elements are have different masses. You can think of here as isobars. We will be studying about the isobars in the next chapter. For example, if carbon has an atomic mass 14, so there is a nitrogen which also has atomic mass 14. They are the atoms of different element, but they are having same masses. Okay. So therefore, your point number 4 also comes out to be false. Atoms combine in the ratio of small whole numbers to form compounds. So we will see this one also. And the sixth one, the relative number and kind of atoms are constant in a given compound. So for any given compound, the relative number and kind of atoms is constant. Okay, this is correct. So these were the points of Dalton's atomic theory. Any doubts regarding this?
No, sir.
Rikshit, you are not participating?
No, sir, I'm there.
Okay. Okay, you see the last question. Which postulate of Dalton's atomic theory is the result of law of conservation of mass? Out of all the 6 postulates, which postulate is the result of law of conservation of mass? Just read all the 6 points and which
Sir,
point
me,
is
sir.
yes.
Sir, I have to answer.
Which one?
Sir, did you ask a question to me or?
Oh, I'm asking to everyone. If you can answer,
Sir,
that
I
will
can
be
answer.
okay. So, which postulate of Dalton's atomic theory is the result of law of conservation of mass?
Sir, for conservation of mass, sir, it's that one. Like atoms can be neither created nor destroyed in a chemical reaction.
Yeah, atoms can neither be created nor be destroyed in a chemical reaction.
Sir, is it not the fifth one that states that? What's the number?
Okay, let's check here the number. No, it's not the fifth one.
It's okay, it's
It's
the second one.
it's the second one. Now, which postulate of Dalton's atomic theory can explain the law of definite proportions?
This is the fifth one.
So
This
this is
is
the
the
fifth one.
fifth. Yeah, okay. Okay, so this is the fifth one. We have completed what we have decided today. But next class is very important. In the next class, we will be discussing about formation of ions and molecules, their chemical formula. Okay. Bye everyone. See you in next class.
Thank you, sir.
Okay, bye.